So what do we want to be able to do? Multiply polynomials. Okay, there's essentially three main steps you have to go through. So our three main steps are, we need to distribute. So you need to distribute multiplication through plus and minus. So because polynomials are plus minus numbers most of the time, and then we're trying to multiply them, anytime you're dealing with different orders of operations, you have to do some kind of distribution. So we've got to distribute through the plus and minus. So usually that means we're distributing the first polynomial distributes THROU through the second polynomial. Okay, there's two major strategies. So there's two strategies generally that you see when you're doing this. One is the basic distribution strategy. You just go ahead and distribute everything and write it out. And the second one is called the box method. So distribution and the box method, okay? Essentially, once you've distributed, you need to expand everything. So everything that can be multiplied should be multiplied. Multiply all possible sets. And then third, you want to simplify, which basically means combine your like terms. Okay, there's basically three steps. That's it. Okay, so that's the English. We distribute, we expand, we simplify by combining like terms. And those are the basic steps for multiplication. A bunch of example problems. Okay, so we're taking our value set. This one, notice on A, that is not an added or subtracted value, that is multiplied value. So I'm taking this single term, because no plus or minus, and I'm going to distribute through the polynomial set of three terms. So once I've done that, I should end up with three values. So I'm basically saying, okay, my original set, 7x squared y plus 3xy minus 11. And what I'm doing is saying, okay, I'm distributing through xy, negative xy, negative xy. So through the original three set, I multiply through by negative xy. Then on each set, you just do the multiplication. Oh my gosh, I don't know where that went. Okay, so I'm basically taking like this, multiplying that, that's my first term. Multiplying that, that's my second term, and then multiplying the third one, that will be my third term. So you just go through and do it. So 7 times -1, -7, x squared times x, x to the third, y times y, y squared. 3 times -1, -3, x times x, x squared, y times y, y squared. -11 times -1 plus 11, and then no other variables, so just x, y. The only time you can change exponents, so notice I'm changing the exponents here, and the reason why is because I'm multiplying, so exponents are representing my repeated multiplication, and then that one is my answer, okay? On the second one, I have a first polynomial of m plus 3, and notice this has now 2 terms because of that plus sign. So I've got this plus sign in the middle, which basically says I have both an m and a 3, and both of those need to distribute through because of the minus sign, so it's 2 terms by 2 terms. So I essentially take the m and I multiply it through the second polynomial. So m times m, and make sure you're over here on the second one. Don't multiply into itself. So m times m is m squared, m times -8 minus 8, m. Then I've got the 3, so I haven't done the 3, so the 3 is now also needs to distribute through, plus 3m minus 24. So standard set, you just write it all out in a big line like this, and then you look for your like terms, which are here because there's an m and there's an m, so -8 plus 3. And my final answer is m squared minus 5m minus 24. And then I'm done. All right. So C and D work the same way. I'm going to do C. I'm going to use a little bit of a strategy on this one. So same idea, 3x distributed through. 3x times 5x is 15x squared. 3x times -2 is -6x. And essentially, that takes care of my first term. I've distributed through the 2 terms on the second polynomial, and I have 2 numbers there, okay? Sometimes you'll see people do this, and they're saying, okay, here's the second term, and I need to distribute that through. And I'm going to actually move down a row, and I'm going to do it below. So I'm going to say, okay, that's going to be 5x plus 5x minus 2. And I'm doing that because it helps me break it up a little bit. Not such a big deal when you've only got 2 and 2, but when you start doing 3 and 3, it is helpful to kind of break it up. So I'm saying, okay, so I know I have 2 terms in the first, so I'm going to have 2 rows, 2 terms in the second. That means each of these rows needs 2 values. And then since I kind of stacked it this way, you should notice that my like terms generally, most of the time, will line up on top of each other, which makes my last step of putting in my final answer a little bit easier because things kind of line up a little bit better. So 15x squared minus x minus 2. Okay, then we have some people who there's just kind of a lot of processing. You've got a lot of stuff going on. So this particular strategy of distribution, this is your standard strategy, is a little confusing. So then we have a whole secondary strategy, which is called the box method. So in the box method, essentially you draw a box. And in my box, essentially you need a space for each value in your polynomial. So I'm going to take the first polynomial here, and you just put it down the side of the box. So -2z plus 5. Each term in the polynomial, there's a space in the box for that polynomial. The second polynomial, across the top, -5z minus 8. By the way, it doesn't matter which one goes down the side and which one goes on the top. That's just sort of what I do standard. You just need one of them on one of the sides and the other one on the other side. And you need a space for each value. So there should be basically an empty square for each of the values that you've got, okay? Then when you're multiplying it, essentially, how do you fill in this box? Well, you take this number, which is in the front, this number that's in the top, and that box, that top left box, gets filled in by multiplying those two. So negative 2z times negative 5z, and I get 10z squared. Next box, negative 2z. On the top, negative 8, so I'm saying negative 2z times negative 8. 16z. Next box, bottom left, 5, negative 5, so 5 times negative 5z, negative 25z, and then the last set is 5 times negative 8, negative 40, okay? In this method, it also sort of lines up most of the time. It'll line up your like terms. Should see that basically I've got z here, 16z minus 25z. So down the diagonal is the like terms that need to be combined. So then my final answer is I combine them. I'm going to end up with 10z squared, 16 minus 25, negative 9z, and then minus 40. And that is my final answer for D. All right, so distribution, distributing t squared. So I'm on E. 2t cubed plus 9t squared. And I'm choosing to bring this down below, negative 8t minus 36. On this one, I'm noticing that I have t squared here, but unfortunately, I only have t there. So this one is not going to work out for any like terms because none of the variables, and in fact, t cubed is also different. So all three of them are different. And then 36 is just a number. So none of this combines with add and subtract. So my final answer is just the whole set, 2t cubed plus 9t squared minus 8t minus 36. Okay. F, happy little boxes. Draw my box. I see I need 2 down the side because there's 2 terms here. 2u squared minus 1. 2 across the top, because I have 2 terms here, negative 5u squared plus 4. And then I multiply as before. So off to the side, up to the top. Those are what I multiply. So negative 10u to the 4th. 2u squared on the side, all the way over to 4 on the top. So 2u squared times 4, 8u squared. Negative 1 times negative 5u squared. 5u squared, and then last, negative 1 and 4. So negative 1 times 4. All right, and I have an error. So I'm looking at this, and what I'm noticing is that I cannot have a square here, a square here, and a square here. So I've got too many squares. So looking at this, I can tell I messed up somewhere. And where I messed up was u squared times u squared should be u to the 4th. I think I said that and then I didn't write it down right. So again, I like the box because it helps, at least helps me figure out if I make errors, which are honestly pretty common. So then u squared. So I do have some like terms and they're on the diagonal as I would expect them to be. So my final answer, negative 10 u to the fourth plus 13 u squared minus 4. And there's that final answer. Okay. So hopefully fairly straightforward on 2x2 sets. So now the last part of this is ones that are a little different or a little more challenging due to one thing and another. This one, G and H. Be careful because this is not b squared plus 25. You cannot just square the numbers and call it good. The problem is squaring is multiplication and you have addition in there, and addition is a different type of operation. So you can't just square it, okay? You need to actually say that is z plus 5 times z plus 5. And I expect to see that on your papers, guys. I expect to see that you actually expanded it out into what it actually is, because then it's a 2x2 set. And then I do the same thing as I've done before. So I'm distributing z squared plus 5z, and I'm distributing the 5 plus 5z plus 25. Like terms nicely line up in my column. So final answer, z squared. I hate z's. They always look weird. That should be 525. So let's try that again. Z squared plus 10z plus 25. Okay, same for the other one. That's 2x minus 3 multiplied by 2x minus 3. So, and once again, if you're doing the box, you have to, no matter what it is, you do need to expand that out into your box set. So 2x minus 3 down the side, 2x minus 3 across the top, filling in my values, 2x times 2x, 4x squared, 2x times negative 3, negative 6x, 2x times negative 3 again, negative 6x, negative 3 times negative 3, 9. Like terms are happily down my diagonal again. So there's my x's. So I combine those. 4x squared minus 12x plus 9. Like grabbing some tunes here. All right. Are we good so far? Are we good with the squaring? Are we good with the fact that we must expand it? Okay. So you need to expand it and then you need to distribute it. Okay. Anytime you've got plus or minus with multiplication, there must be some sort of distribution going on. So do not take shortcuts because that will mess you up. All right. So I and J, these are almost the same as what we did before, except now we have one is plus, and then the other one is exactly the same, except it's subtraction. So one is plus, the other one is minus. So they're almost identical, except one's plus, one's minus. So they're sort of opposites. And so you get something interesting happening. If I distribute, I'm going to get n squared minus 3n, and then plus 3n minus 9. And what happens in the middle here is, since I've got this minus 3 plus 3, this turns into 0. So my final answer is n squared minus 9. So that happens because one of them's positive and one of them is negative. Okay, so they're actually, it's not like I just squared the values. I basically, hey, the middle term drops because of the fact one is positive, one is negative. On the other one, if I do the box, what I'm doing 5y minus 2, 5y plus 2, so down the side across the top, 25y squared, positive 10y, negative 10y, and negative 4. And then once again, I've got y, and I've got plus and minus. So all of that just drops in the middle because plus 10 minus 10 is 0. And I'll be left with 25y squared minus 4. Okay, notice that though, the reason why that worked is because I did actually distribute it and the middle term happened to go away. Okay, so the last two. All of the others were basically a little bit more challenging. Some of them were squares, some of them had addition, some of them had subtraction. The last two are harder because they're just harder, because they're bigger problems, because you have more terms in your polynomial, which means you're going to have to do more work. So K, if we do distribution, here I am, 2x. And I'm distributing it through a 3-term polynomial. So when I distribute it through, I should get 3 numbers as my answer set, okay? So 2x times 5x squared, 2 times 5 is 10, x times x squared is x to the third, 2x times negative 6x, 2 times, so basically you multiply the numbers, multiply the variables, 2 times negative 6, negative 12, x times x, x squared, 2x times 7, 2 times 7 is 14, and then just x because there's no other x to multiply. So there are my 3 values that I got when I multiplied through by positive 2x, sorry. Then I have a second term. My second term is negative 3. So that needs to distribute through as well. There's my final answer with all my like terms added together. All right. Generally, the more terms you have, the more likely it is you're probably wanting to use some kind of strategy to organize it so you don't mess it up. All right. On the next one, it is a 3-by-3 set. So a giant box, a 3-by-3 box. I need 3 rows for my 4x squared, 7x minus 3. And I need 3 columns for x squared minus 2x and 8. So one polynomial down the side, the other polynomial across the top, and basically one box for each number, okay? Then I just multiply into each box. So 4x squared, x squared, 4x to the fourth, 4x squared, negative 2x, negative 8x cubed, 4x squared and 8, 32x squared. That takes care of the first distribution. 7x and x squared, 7x to the third. 7x and negative 2x, so 7x times negative 2x. By the way, one of the most common errors I see on these is instead of multiplying, and I see this, instead of multiplying them, you end up adding them because there's a lot of addition going on, so you make a mistake. So negative 14x squared. And then 7 times 8, 56. I think that's right. Okay, so last row, multiplying 3 by -3. -3x squared, 6x, -24. Okay, so looking at like terms again. There's x cubed, there's x cubed. So like terms down that diagonal. There's x squared, and x squared. So all of these are like x squared. So I can add those together. Last one, I have some x's and an x, and they are also down the third diagonal. So I've got 3 diagonals going on, and all 3 of them have my like terms, okay? This one works out nicely because of the fact I don't have any weird stuff going on. It's x squared, x and a number. Second polynomial is also x squared, x and a number. Generally, that's your polynomial sets. If you have other stuff happening, like different exponents, then you might not get your like terms lined up like this. So you just got to make sure that they're okay. Just check to make sure that your exponents are correct. I also look like if my exponents are weird, I check back to make sure I didn't mess up my multiplying, okay? So then the last step, so this would be showing your work, guys. The more complicated your problems are, the more I expect you to show work, okay? Okay, so my last step here is to write my final combined answer. So 4x to the 4th, 7 minus 8 is -1, so negative x to the 3rd. Oh my gosh, 32 minus 14. What is 32 minus 14? Oh my goodness, 16, 18. 18 minus 3, 15. I think that's right. 15x squared. I'm doing that in my head, so I am not. I'm not dedicated to that number, so hopefully that's correct. 6x plus 56x, 62x minus 24. And that is my final expanded answer, okay? So that's our goal for the day, is being able to basically find out these values and multiply them and add the like terms together. So multiplying your numbers, multiplying your variables, getting your correct exponents, okay?